13d, and we're going to look at the tetrahedron. But first we're just going to review this triangle. We looked at this 4, 5, 6 triangle before and considered all the possibilities of it and understood that as long as you keep the height the same, you can move this vertex anywhere along this line and the volume stays, or the area stays the same. So so that means that we understand that there are a lot of possibilities for this triangle to have the same area, because we showed you that in the other video. Now we're just going to turn this triangle into a tetrahedron by doing this. Okay, now we have a tetrahedron with 4 triangles that all obey the same rules as the base triangle. But we can see that we know of all the possibilities we have for keeping the base triangle the same. Now, as long as we keep the height of the tetrahedron the same, we can create any number of tetrahedrons that have exactly the same volume, because the base and the height of the tetrahedron are remaining the same, right? Now, interestingly enough, if we kept this height the same and continued out, we have a limit of our elasticity here, but theoretically we could, if we had enough elasticity, we could go parallel to this base all the way to the moon, and we'd still have the same volume of 16.533, which is 1/3 of 992 times the height, which is 5 in this case. So that's pretty interesting. If we took this and just stretched it this way, increasing the height all the way to the moon, we'd be increasing the volume. And I think that's really an interesting concept. But anyway, so here we're showing this incredible calculating ability of triangles, and then when manifest in the tetrahedron, it becomes even more incredible, because as this triangle here moves along, this face right here, it's actually the height of the triangle is not staying the same. It's the height of the tetrahedron which is staying the same, so that this thing is calculating in so many dimensions at once in order to keep that volume the same, that it's incredible to think about that. So anyway, that is pretty much what I wanted to show you in this video. That, of course, the formula for volume of a tetrahedron is the area of the base divided by 3 times the height. So in this case, the area of the base is 992 divided by 3 times 5 is 16.533 is the volume. But I really want you to think about the constancy involved here. That with this constant volume, we have, for all practical purposes, an unlimited number of variations, because not only can all these 3 triangles above the base be varying, but also the base can be going along this line and maintaining the same area. So it's I think of these things as computers, really. So anyway, that's all I've got for this one.